Hello and welcome. Welcome to the PowerShell virtual meetup from New York City. My name is Doug Fink and I'll be hosting tonight. And looking forward to Jan presenting on getting started with dev containers and VS Code. He's over in Norway, so it's late for him. Really appreciate him joining us tonight to drop some good knowledge on us. Before we get started, I just wanted to point out next month, Aaron Nelson, former MVP, PowerShell MVP, or SQL MVP. He's now been at Microsoft for a couple of years. He'll be walking through a presentation about PowerShell runbooks and Azure automation accounts, which is, if you use those, if not, they're pretty interesting to check out. And the last thing I just want to draw your attention to is I post all these meetup recordings up here on this YouTube channel. I'll post a link into the chat. You want to get on there, check out what other speakers have done over the last year or two, as well as you want to subscribe to the channel and click the notify button so you know when I post other meetups coming up, as well as other types of content I record about PowerShell and other technologies. So let's kick off. So in this session, we'll see how to get started with dev containers in Visual Studio Code. If you don't know what dev containers are, Jan will walk through some of that, what that means and how it works. It's a very cool way to do development, even at the PowerShell level. And Jan is a lead architect at Crayon over in Norway, mainly works with automation and has a strong passion for PowerShell. Jan, how long have we known each other? On or about?
I think it's 10, 11 years.
Yeah, so I really have always enjoyed Jan's work that he's done out in the public. This is the first time he and I are actually talking and hearing each other talk to each other. We've communicated through text messages and emails over the years about all kinds of cool tech. So I'm looking forward to the presentation. So with that, Jan, you want to share your screen and kick off?
Yes, thank you very much.
Okay, and while he's doing that, if you have any questions, feel free to post them in the chat. I'll keep an eye on the chat and set those questions up for Jan. We'll go for about 45 minutes. And okay, Jan, you're up.
Cool. You can see my screen?
Yes, I can. Looks good.
Yeah. Do you also see this Zoom menu bar, or do you see only the slides?
Just the slides.
Okay, cool. Welcome everyone to this talk about the containers in VS Code. As Doug just mentioned, I work at Crayon in Norway, which is a company that do consulting, licensing, cloud economics, and other services. I've worked there for about 12 years, and actually today is my last day there. So I'm very excited to announce that I will start working as a cloud solution architect at Microsoft on Monday. So really looking forward to that.
Awesome. So, congratulations.
Thank you.
So no longer an MVP?
Yeah, correct. So I'll be on MVP until Sunday, and then I'll be a blue badge on Monday.
Awesome.
Oh yeah, that will be fun. So the agenda for today, I'm going to do a brief introduction to Docker and containers, in case someone haven't any knowledge about that from before. And before we dive into the demos, we're also going to show what challenges do we have when working with the development, even if it's a PowerShell script or Terraform or infrastructure as code or regular programming languages. It's common challenges, and this can solve hopefully most of them. And of course, there will be a lot of demos at the end. So if we start looking at the development environments in general, most people use VS Code, at least for PowerShell development these days. Most people have transitioned from the PowerShell ISE. So then you typically have, of course, the PowerShell extension, but you also have a lot of other extensions. Then you have version X of PowerShell. Some people are still forced to use, for example, PowerShell 5.1 because they are working with Windows-based environments where that is used on the server side, for example. Then we also have a lot of modules in PowerShell with a lot of different versions. For example, the Azure PowerShell versions, when you have a major version change there, you have breaking changes like everything else. Same with Terraform. If you work with infrastructure as code or Azure Bicep, Azure CLI, and all of these other tools that we use in our day-to-day work. Linting tools, Pester, for example, and so forth. And in addition to all of these potential inconsistencies on the developers' workstations or your team's workstations, the users also might have different operating systems. So even when you are on the same operating system, if everyone is using Windows 10 or Windows 11, for example, there might even be different patch levels that can cause unpredictable results. So incompatible versions of prerequisites and so forth. So there is a lot of things that can potentially go wrong. So the goals we are trying to share here with the dev containers, it's first and foremost isolation, that we want to keep environments like test and production separated. So if you're a consultant, you might be working with multiple customers like I do, and you don't want to constantly be logging in and out of the CLI or the Azure PowerShell, for instance. And it's also a risk if you, for example, is logged into the wrong context and run a command against the wrong environment. Then it's also a risk to use a single shell or single environment for multiple customers, for example. The next thing is that we want a standardized format so that every team member use the same versions for a specific project. And it's also beneficial for yourselves. Even if you are the only person in a repository, for example, you might roam between devices, you might have a work laptop or private laptop where you could benefit from a consistent environment. So for example, if you check your code into Git, your state will be stored there. So the code will be in sync across the devices, even if you have two different containers on two different machines. If you have everything in Git, it will be the same on both of them. And of course, the last thing that we want is to avoid this the famous "it works on my machine" scenario, because the developer that created something had some prerequisites or some different versions that made it work on his or her machine. But yeah, so this really makes it possible to share configurations via Git, for example, and share a single configuration. So as you might know that this sounds familiar. So the first question before trying to reinvent the wheel, is it an already solved problem? And of course, in the name of the topic today, dev containers, we are of course talking about containers. So what is a container? I like to look at the analogy where we on the left side look that we or imagine that we virtualize the hardware. So we create one or more virtual machines on a Hyper-V host. It can be, for example, Hyper-V server from Microsoft or VMware. Create virtual machines and install separate instances of the operating system. On the right-hand side, on the guest operating system, we install a container engine, for example, Docker, which is the most famous or most used one. And on top of here, you virtualize the operating system as opposed to the hardware. So you can have multiple processes, that is separate containers that have their own view of the operating system. And from their perspective, they think they own the whole environment because everything is virtualized for them. So here you get the benefit that you get, for example, higher density. You can put more workloads on the same operating system. And and when we talk about containers, there is a lot of terms and things that might be unfamiliar. So I also just wanted to talk briefly about those. So if we start with images, the custom images is where your application lives. So for example, you can have an image with, for example, the PowerShell team publishes every time there is a new version of PowerShell, there is a new image available on Docker Hub, for example. Registry, that is kind of an app store for containers, a central location that you can download images from. So Docker Hub, which I just mentioned, which is a common example. But for example, cloud vendors, they have different offerings. In Azure, you have Azure Container Registry. In AWS, you have a separate container registry offering. So you can host a private registry to publish things that is only internal to the company, for example. And the last piece is the container itself. So the container, as I mentioned, is a process on the container host that can be either physical or virtual, running an instance of a container image, which is fully isolated from other containers and the host. So combined with a container orchestration engine such as Kubernetes, this can scale tremendously and is being used by many customers today. And we will now see how we can benefit from containers when it comes to a development environment for PowerShell and infrastructure as code, which is kind of my personal background. But as I mentioned, if you are a developer working on traditional programming languages, you can use this in that scenario as well. So the last piece of theory before we dive into the demos is the VS Code extension. So here you can see how the architecture looks like. The local operating system is your laptop typically, or your workstation where you have installed VS Code. When a container is being created, a small VS Code server-side component is being dynamically injected into the container, making it possible for the local VS Code to communicate with the container and look into the file system, see the processes that is running, attached to the debugger, and so forth. And as you can see at the bottom, it also creates a volume mount point so that the local folder where your code lives is mounted into the container, because by default, containers are ephemeral. So when a container is stopped, you lose all the changes that you have done inside it. But if you use mount points or mount persistent storage, you can persist your data. So the VS Code extension for this is called Remote Containers. It was released, I believe, in 2019. So it's been around for a few years. Personally, I started to use it, I think it was one and a half year ago, probably. And I've been using it when working with customers ever since, and it has really been a game changer in order to have control and have dedicated instances per environment, basically. Even when working with the same customer, you can have a separate container for production and so forth.
Hey, Jan,
yeah.
Is that also, I don't know if you're going to get to it or if it's important, that also connects up to the GitHub code spaces?
That's correct. So GitHub Codespaces is actually a very similar offering. It's a different extension that is called Codespaces, but it works exactly the same as you see on this picture, except that the container is not running on your machine. It's running in the cloud. So the benefit there is that you can have a low performing laptop with just a 4 GB of memory, for example, and you can run a huge container on the cloud up to, I'm not sure if it's up to 64 gigs or something. So it really makes it possible to run demanding workloads locally, or for you it feels like it's local, but it's actually running on the server side.
Cool, thank you.
So Docker Desktop, the prerequisites, it's Docker Desktop and Visual Studio Code running on either a Linux machine, Mac OS, or Windows. Docker Desktop, I believe they started to license the product. So if you use it commercially, you have to acquire a license, but for personal use, it's free as far as I know. I have to double check, but it wasn't changes on the licensing side. I believe it was last year. As an alternative, there is other container engines available as well. For example, if you work with Red Hat, you have Podman. So Podman can also be used with VS Code, and I believe it does work with this dev container extension as well. So that was the last piece of theory. Then I'm going to dive into the demos and show you how it looks like. So here I have, right now I'm on a Mac with the Apple Silicon, but I also have a couple of other machines available where I can show you the other operating systems as well. The prerequisites I just talked about, so it's already installed on this machine, both Docker and VS Code. If you don't have it, you can find the links here. I have the code already shared on my GitHub, which is linked at the end of the presentation. So the first place you typically start is to find yourself a base image to work from. So when we talk about containers, hub.docker.com is where you find many of the common things you want. So for example, if you search for PowerShell here, you can see the official PowerShell images from Microsoft. And if you scroll down here, you can find the syntax for how to download the latest stable image. You can find the full tag listing if you want Windows images, for example. So there are also Windows containers, but then you need to run it on a Windows-based host. And you have Linux images that can run on both Linux, Mac, and Windows. So here you can just pick and choose which operating system you prefer. It's of course different sizes. So for example, the most common distribution is maybe Ubuntu because it have a lot of common utilities installed. While we have this in the other end, we have Alpine, which is kind of a built for containers, very minimal image. I think the base image is something like 70 megabytes or something. So it's really, really compressed, but then it is lacking a lot of the tools that you use. For example, I think it even don't have, for example, a ping command or maybe not even ls. So it's really, really stripped down to save space. When you have found the image you want, in this example, I'm just going to use the Azure CLI that I found on Docker Hub and copied the syntax for the name of the image for the latest tag, the newest available. You don't have to learn how to run Docker manually in order to use dev containers. I just want to show how it works on a basic level, just to give some background. So Docker and then run, and then you can have some optional parameters. For example, if you automatically want the container to be removed when it is stopped, then you have to specify this parameter. If not, it will be lingering. It will be stopped and still available on the system. And if you want an interactive shell, you have to specify IT. And after that, it's the name of the image, and that's it in order to run it. So in this example, if you look at my local machine, I don't have the AC command available because it's not installed on the local machine. And if I run this command, it should spin up a new container. And here I get into the bash shell inside of the container. In my case, I'm using Apple Silicon, as I mentioned. That's why I get this warning about the requested image platform. It's downloading the AMD 64 version for Linux, which does work on ARM 64, which is the Apple Silicon, but it's emulated. So it's more optimal to use the ARM 64 V8 if available, because then it will be kind of native on better performance. But the Linux images, they are going to be on emulator, so it might be lacking performance, but for my use, interactive command line usage, I don't notice the difference basically. But if you compile applications and things like that, you can of course notice. And if you have the AC command here, you should see that it's available with the latest version, which is 240, I believe. Yeah. And when we are finished, we can just exit out, and then the container will be discarded. It will be stopped and discarded when I go out of it. If this image is not downloaded, when I run this command, it will be dynamically downloaded for me, but I can also pre-download it or pre-stage it by using Docker pull. So This is the syntax for that one. Alpine I already talked about. Yeah, there is also an image that is down to only 5 megabytes inside. That's that's really crazy, talking about when you compare it to virtual machine images, that is maybe 5-10 gigabytes if it's Windows images. So yeah, so Alpine is very popular for some cases where you don't need the interactive tools, for example. In order to see the images that you have downloaded, you have this Docker image list command. So here you can see what is already downloaded and available on the system. So here you can see that the size of the images varies a lot. Some of them I have built for interactive use with the customer scenario I talked about, and install a lot of things. And then the image can grow and be quite big. But for the smaller ones, it's, as you can see, a couple of 100 megabytes. If it's only on the PowerShell, for example, it's typically 200-300 megabytes. A great use case also is that when there are new PowerShell versions available, you can test out the previews without installing them on your machine. So for example, now the latest preview for 7.3 is preview 8, I believe, and then you can just go ahead and download and run it. So Alpine is one option. Actually, Microsoft also have created its internal Linux distribution called CBL Mariner. Initially, it was created for their cloud infrastructure in Azure. So a lot of the platform as a service offerings, for example, is using this under the hood. But now they have also opened it up and made it available, so we can go to GitHub and see the source code, I believe, and it's available in the form of Docker images as well. So here I can, for example, run the latest LTS version of PowerShell on Mariner, just to have a look. And here you can see that I get 726, which is the latest one. So it's really a great way to test new versions. Yeah, and the PowerShell boundaries, I think I mentioned, but here you can see the sizes from 200 to 300 megabytes approximately, depending on which image you are choosing. You can also look into each of the layers and so forth if you're interested in how the Docker image has been built, because all of the images that are uploaded here is based upon a Docker file, which you can think about as a kind of a build script that specifies what should be installed inside of the container and so forth. So the key points from this initial basics demo is that the containers are very small and lightweight, and that it provides isolation and consistency, I would say. Data I also talked about. So if you want to create the mount points manually when you use Docker run, you have to specify -v for volume, point to the local folder and colon, and then the remote folder inside of the container that you want to create a mount point against. But as I mentioned, this you don't have to worry about, because VS Code is handling it for you when you open a folder in a dev container, but this is what is happening under the hood.
Okay, we have a question from Clem. He's asking, how did you get your company ISO to sign off on allowing DevOps the freedom to pull whatever images they see fit from Docker Hub?
Yeah, so in this case, it's my personal machine at home, but it really depends on the customer, what is allowed and not. At many customers, you get a physical machine with their own kind of restrictions. So some people even don't, or some customers even don't have internet access. So it's only pre-approved software that is available. So if you are in such a scenario and you want to use a specific image, you can, for example, request if it's possible to get the image available from an internal registry. So the customer can set up, for example, a pipeline that will pull the image, to a local build server, scan it for vulnerabilities, and then push it to an internal registry, for example. That's one approach. So yeah, really depends on the customer, I would say. And then we have, if we work with Docker or containers in production, then you have persistent storage in the form of Azure disks, for example, or Azure files when we talk about Azure. So the cloud providers have their own ways of providing drivers that will make it possible to mount persistent storage. But for our scenario, we're just using mount points to local folders. So then we're going to look into the extension. So the first thing is the documentation, which is really good. It does go through a lot of details, if you see on the right here, about how to specify settings inside of the dev container JSON file, debugging inside of the container, sharing Git credentials, and so forth. So there is a lot of good information. I would recommend to just go through this document quickly before you start using it, because it answers a lot of common questions. So now I'm just going to run a demo on the Mac here. So let's first just remove the one that I have there. So yeah, so here we have a couple of files from earlier. I'm just going to delete them. So we have an empty folder. So the first thing you need to do is to install the extension. So if you just go and search for remote, I believe, on the extension marketplace, you should find remote development. This is already installed in my case, but this is the extension that you want, in addition to Docker, of course, installed. So when you have this installed, you can go ahead and open the command palette in VS Code, search for remote containers to get the options they have there. And the first one, in order to get a skeleton, is this add development container configuration files. Then it will provide kind of a wizard-like experience here, where you can choose some starting points, for example, Alpine or Debian or Ubuntu container with common utilities installed. If you do show all definitions, you can see that there are a lot of different starting points there if you work with specific languages and so forth. So PowerShell, for example. And then you get the skeleton, you get the .dev container folder created, and inside of that one we will have dev container.json, which is kind of the settings file for VS Code, the extension, and you have a plain regular Docker file. So if you have worked with Docker from earlier, you can just reuse your knowledge and add custom things here. Just add run commands and install software like you're used to, for example, or copy files and whatnot. But if you are not familiar with it, it's fine, because you get these starting points that are working just fine. When you have created and selected, for example, the PowerShell starting point, you can go ahead and click on the lower left there, open a remote window and reopen in container. That is the option that will take this local folder, run Docker build under the hood against this Docker file, so that it will create the image for us and run an instance of a container against that image. So let's just go ahead and do it on this one. And you can also show the log from the build if you are interested in the details. So here it is already up and running. You can see the container column PowerShell. So PowerShell was the name that was specified in the file. So if you specify something else here, I typically have the name of the customer, for example, NYPS meetup, for example. So if you do a change, you can just rebuild the container, and it will show up the next time it launches with the updated name here. Just reopen it locally again. Yeah, I'm just going to close that one. It was hanging on something there. So I have some pre-customized examples available as well. So if you look in my demo file here, we have controls and management. So if you look into that one, here you can also specify things like what should be the default integrated shell. So of course I want to use PowerShell, so I specify that one. And you can also specify which extensions you want, because you do not automatically have the extensions that you have locally. Those are not available by default inside of the container. So you have to either install them manually after the container has started, or you can specify the ones that you want in this extensions array. And then those will be installed automatically when the container is being built. Here you can also do extra stuff if you're, for example, creating an application and want to do port forwarding to your local machine for testing some web front end or something like that. You can also create manual mount points here if you want. You can also specify what features you want to install. Common utilities is available that can be installed automatically, so you don't have to do it in the Docker file, but you can simply just specify it in this features option. So that's also very handy. And for the Docker file in this example, I have based it from this .NET Runtime 6.0 as an example, and installed some other prerequisites for things that I'm using. I was also hoping to show .NET Interactive Notebooks, but I was not sure whether we need to install the prerequisite, which is the .NET 6 SDK inside of the Docker file, or if it's available inside of this image. I think we have to install it because it didn't work when I tried it before the presentation. So if we have time, I can try to rebuild it and see if it works, but I didn't want to break my demo 2 minutes before we got started, so no, we don't have it. As opposed to installing PowerShell by specifying the command inside of this feature here, I could also just type PowerShell and latest or a specific version, and the VS Code will handle it for me. But if I want to install something on the kind of manual way that you find in the documentation for PowerShell in this example, you can simply just insert the commands in the Docker file, and it will download it and install it on a regular way that you're used to in Linux. So this is the commands that installs the latest PowerShell version. Next, you can also install other things. For example, if you use Posh for your prompt and so forth. Import Excel that Doug has created, which I use all the time for creating all kinds of reports. Really great module. Then you have to have some tools here in order to have some features available. I don't recall if maybe it's the auto sizing of the columns, if I recall.
Got it.
Yeah,
that's right. Thanks for mentioning the module too.
Yeah,
awesome.
No worries. I have used it so many times, so yeah, it's really great.
Cool.
So these libraries are needed for the auto sizing of the columns. When I started using this myself a year and a half ago, I didn't share my dev containers with others yet. I was just trying to see how it worked. So in the beginning, I did typical things like I did in my PowerShell profile in order to customize things. I installed PS readline, installed all kinds of PowerShell modules using PS depend, and really hard-coded my PowerShell profile as part of the project, really. So this was perfectly fine if I worked only on the project myself, but as soon as I share this with someone, it's kind of very opinionated if I have already pre-created a PowerShell profile and so forth. So when I do it for team projects, I simply don't do it this way. Then I use another way that is called dot files. So dot files, that is something that is mentioned here in the documentation somewhere if you just search for dot files. But if I go to browser and search for my dot files repository, there you can simply point to a GitHub repository. In my case, this is my repository. If you specify the URL, we can copy it now and do it afterwards. Then it will search for a predefined set of files. So install.sh is one of the files that is searching for. From here, I'm just calling PowerShell. I'm pointing to install.ps1. And inside install.ps1, it goes ahead and creates a config directory in my home folder with a symbolic link to where the dot files are stored, and inside of the config file I have my profiles. So here I have my themes for all my posh and all of the different personal profile settings. That is something that I use for my personal preferences. So then I have all of these things separated from the container, so everyone can have their own personal settings. So in order to specify the dot files repository, I have to go into preferences, settings, and search for dot files. And here I can simply insert the URL to the repository. And the next time I build a container, no, it was for my local one, but if I do it for the remote containers, then it will also automatically clone this repository and trigger that install.sh after the build has been performed. So I can try to see if I can get it started here. It does take some more time when it is downloading and installing things, because as you saw in the repository, it is actually installing a lot of PowerShell modules. So I think it was here requirements.pst1. So a lot of the Azure modules, for example, they are quite big. So installing all of these base modules that I often use maybe takes a couple of minutes. So the first time that the container starts, you have to wait a couple of extra minutes, but then it won't need to rebuild until you make a change. So for example, if you bump the version numbers or some module here, you have to rebuild, and then you have to wait 2 minutes again. But if you just close VS Code, reboot your computer, start the dev container again, it will use the built image, so you don't have to wait 2 minutes every time. It's just when you have made a change, basically. And of course, import Excel is is on my list here.
Nice.
Yeah, that's mandatory. Let's see. Yeah, and if you move on to the next file, which is customizing the environment, here I've already started talking about the dot file. So for people that have worked with Unix or Linux systems before, they might have been used to configuration files, for example, .bash profile or .git config. So it's basically kind of profile settings that can be used across computers or across containers in this scenario. And also there are a lot of good documentation here. So if you're interested in really see what's possible with these things, it's a lot of tips and tricks and things available in the documentation there. Yeah, and I suppose everyone in the PowerShell community is aware of the PowerShell profiles, but in case you're not, these are the places that you can store them. So basically what I was doing in my dot files is that I'd create a symbolic link to this one so that I can have all my push and all of my PS readline settings and so forth available here. One little gotcha when I started using this is that this install.sh script needs to have the executable bit set. So it didn't simply work. I had to troubleshoot a little bit before I found that I had to just set a bit and commit, and then it worked on the next time. So it's useful to just log things to a file in order to see what is happening. If something fails in the bootstrap process, you can see it in the log file. The next thing I have created is this control management container that I just showed you. So we can switch to a different machine. So if you go here, we have a Windows machine, and here we have actually already started VS Code. Let's see if the machine reconnects. We have started VS Code with the dev container already running. I think the machine disconnected. Yeah, it's prompting me for a password on the other screen. There we go. So here you can see it says dev container controls management in the lower left. So the container is already running, and it's looking exactly the same as it did on the Mac. And if I go to the third machine, this is actually on Ubuntu 22.04. So if you look at the terminal here, you can see it's Ubuntu 22.04 with VS Code installed. I have the dev container controls management running. So everything is looking exactly the same on Linux, Mac, Windows, and Mac. But really shows the consistency that you can get. No matter what operating system you're using in the team or your company, you can have a very consistent environment. So I've been seeing more and more customer, or especially the developer teams, that customers have started adopting this in the past year or so, and I see it really beneficial to get consistency. So one additional tip there is something that one of my customers did. The same Docker file that the team was using for their VS Code dev container, they was using for their build server. So they were actually using Azure container instances as build servers hooked up to Azure DevOps or Azure pipelines. So the pipeline was running on the exact same Docker file or Docker image as the developers were using to create the code. So then you had really consistency over the whole pipeline. Some practical tips and tricks, for example, credentials. Personally, I prefer to use SSH keys in order to authenticate to Git. You can, of course, just use HTTPS and credentials, and they will be stored. But if you're using SSH keys, you must first make sure to, of course, configure your local Git configuration. And you have to add the SSH keys to the SSH agent. So the agent is integrated with VS Code or vice versa. So if the key needed to clone a repository is added to the agent, it will dynamically be picked up if you run, for example, git clone inside of the container and clone a SSH-based URL. It will dynamically use the SSH keys that is available in the agent. So if you're on Windows, you have to start it because by default it's disabled, I believe. And on Linux, you have to have it in your bash profile. And when you have performed that, you can simply run SSH add, like you see here, and add the keys that you need. Doug mentioned GitHub code spaces, so I just have some references here to that. Basically, it's the same thing, but running in the cloud. I know it's also generally available, I believe, so you have to pay for it. But so it's hosted in a virtual machine in Azure, and basically works the same. You can also work with it from a browser in addition to VS Code. So then, if you just have access to a browser somewhere, you can actually connect to your code spaces. So that's really cool.
I guess the other benefit to that is that when you do a code space on a repo, it actually loads up all your code from that repo as well, whether PRs and so on.
Yeah.
And you can actually then test through a browser or through VS Code people's changes to your libraries or for your project that you're working on, and you're just running in a cloud instance, so to speak.
Yeah,
Good stuff.
And also, if you hook up to the same code space, whether you're on your home machine or your work machine, then you have the exact same container that you can connect to. So yeah, it's really beneficial. But since it costs money, personally, I use the containers locally for the customer scenario, but I see scenarios for both code spaces is great as well. But I just haven't used it so much personally yet. But yeah. And also dot files, if you have configured a dot files repository, as you saw in the settings in code before, that also will be picked up and used by code spaces. So you'll get all my push and all your PowerShell settings from your dot files repository injected into code spaces as well. So that's really cool. I don't have a demo for that now, but that is also something that I suppose it will be possible to do a whole presentation about.
Absolutely.
And there are also related extensions that can be mentioned if you work on Windows and you're using the Windows subsystem for Linux. It's actually a remote extension for VSL, so meaning that you can install that extension and connect to your VSL instance from VS Code, so that it will be a similar experience that we have with the dev containers, but it's connecting to VSL instead of the container. So that can be handy. Same with remote SSH. This is also something I use all the time when I remote into some Linux box I have to do something on. For example, at home here, I have a Synology NAS where I run all of my Docker containers with the Home Assistant, PowerShell Universal, and whatnot. Then I just use this extension to connect to it from VS Code, and I have the exact same experience that we saw now. So I can actually show it quickly here. If you open a new instance of VS Code, we go to the Remote Explorer. This is where you can find all of the things, GitHub code spaces if you have it, if you're signed in, the containers that is locally on the machine, VSL if it was a Windows machine, and SSH targets. So for example, if I connect to this, it's a Linux machine running in Azure that I can reach from here, right click and connect to it. And if I have set up SSH authentication, you can see I'm signed in seamlessly. So now it says SSH on the name of the computer, and I'm logged into it, and I can see the local file structure. So I can open, for example, the home folder and work with the remote files as if they were local. So really handy extension in addition to dev containers. And this is also possible to use against Windows servers, for example. If you install OpenSSH server, I believe it's available by default in server 2019 and 2022, but it can also be installed on older operating systems. So if you have a Jumpbox or management server, for example, you can go ahead and connect using this extension to it, and then you can have access to things like the Active Directory module and reach internal resources if you're connected to a VPN, for example. So lots of practical use cases there. I think that was the last demo I had. Let me see on the slide deck what is left. Yeah, this I already mentioned, that you can use the same container image on the pipeline agents. The VS Code team actually published a VS Code dev container CLI that makes it possible to pre-build your images. So instead of each developer having to build it locally, it can be pre-built and published to an internal registry, for example, and people can download it from there. So that is also an option here. Yeah, I think that was the things I had. I have some resources here to the documentation that I showed you briefly. I have also written an article on dev.to that is pretty much showing everything that I showed you today in this article, step by step. And the demos on the slides is available on my GitHub. So are there any more questions in the chat, or does anyone else have any question they want to ask?
That was a great walkthrough. Really good presentation. Thank you. No, I don't see any chat questions at the moment, but I also wanted to throw out, have you done anything with GitHub Actions? Only because, you know, that uses Docker containers as well. So the whole theme here of containers and remote containers, you know, containers are playing a role in so many different places in the software industry at this point. So, but have you done anything with GitHub Actions?
Yeah, I set up a proof of concept for a customer once where we tried to run Terraform. So we got it running there. If you have worked with Azure pipelines and YAML pipelines, it was really easy to transition to the syntax and everything. So my initial impression is that it was convenient.
Cool. And now that you're going to be working at Microsoft, it'll be more convenient, right?
Yeah, I suppose so.
Yeah, so anybody else have any questions? I don't see anybody. I'm going to get those links from you at some point, and when the video is ready, I'll post the video, and then I'll post those links in the description of I post the video up on YouTube.
Sounds good.
All right, I guess no questions, and I guess we're good.
Yeah, and if there are any questions later on, feel free to ping me via Twitter, for example. I'll answer questions there.
Excellent. Well, thank you. Really appreciate you coming on late tonight and walking us through some really cool technologies and how to apply them. I know I got a couple of good tips and tricks, and I've been playing around with this stuff.
Cool. Thank you for having me, and thank you for your time.
All right. Well, we'll be chatting again, and looking forward to see what you do at Microsoft.
Yeah, we'll do it.
All right. Have a good one, everybody.